Hi, I'm Vile Herto. I'm a senior mechanical engineer.
Hi, I'm Kevin Tietz. I'm also a senior mechanical engineer.
And I'm Steven Scott, and I'm an electrical engineer. We're C Team 3, and we are working with the UVM custodial staff to try to form a ice removal tool. Originally, they chipped ice with a mechanical motion, and we were trying to alleviate that physical burden that puts on all of their custodial staff.
So this is an innovative project that many would find useful. Anyone that has had to chip ice before knows that this is a physical burden and takes time. And it's generally not something anyone wants to do. A lot of people just throw salt on it. If it's not done correctly, it becomes a danger to society and pedestrians. So this tool will make the job easier, quicker, and more fun to do, which will in turn benefit the safety of the user and people using the sidewalk. The tool will save time for people whose job it is to clean the sidewalks, and in turn allow for time for them to work on other things like shoveling snow and other services.
So our client's main objectives for this tool were for it to be ergonomic because we want to save the staffs from having to throw out their backs and overwork their arms doing the manual chiseling. We also want it to be efficient, like Vila was saying, so they can save time and focus on other tasks that they have to do within the buildings. We want it to be safe so that we're not harming people in the surrounding area, and we want it to be user-friendly because the UVM custodial staff demographic has an average age around 60, so we want to make it easy to use and not too heavy.
The trade-offs we made in our design consideration for our tool was the plausibility of the design, the effectiveness, safety, and the practicality of the tool.
Alright, so I did some impact energy analysis to help us determine what strength tool we would need. So we looked at the fracture toughness of ice, and then we figured out what impact energy was necessary. We ended up settling on a tool with about 4.7 joules of impact energy. And then the other part that I mainly focused on was working with the battery casing and also with the trigger switch. Originally I had designed a SolidWorks model for a battery casing, but we realized it would be a little too expensive to 3D print, but we were able to order an aluminum casing, and then we still 3D printed this switch casing and 3D printed a custom lever to actuate the tool.
On the electrical side, I had originally planned to create my own motor control circuit, but however, Milwaukee made it very difficult to integrate that into this tool, so I ended up using their trigger to run the tool. However, I used my prior knowledge in electrical engineering and my internship to extend the wires and create a charging mechanism for the battery in the battery casing.
And I used my skills to figure out the mounting component that mounts the tool itself to the shaft. And this was a difficult task just because of the reciprocating motion, the weight of it. So that's why we have two connections here. So this is our final design. Originally it went from having a couple different configurations. We ordered some parts off online and went to Lowe's. And we decided this was the best design. It's pretty tight up front, and then earlier we didn't have this back connection. It was pretty sturdy without it, but we figured one extra connection wouldn't hurt, so that final part was put in.
So with our battery casing design, it's difficult to access the battery and to charge it, so we had to come up with a way to be able to charge the battery within this configuration. So my solution was to create a pass-through knockout battery charging receptacle with this interlock switch, which allows the tool to be isolated when it's in charge mode and when it's in run mode, and also acts as a safety kill switch. So as you can see, when it's in this mode, it is able to run, but when it is off, it can't run, or when it is set into charge, it can't run and would be charging if it was hooked up to the battery charger.
Alright, so I went through a few different iterations on the switch design. Originally, we had it set up so that we could use a smaller switch, but it turns out we had to use the trigger from the Milwaukee tool, which made it have to be quite a bit wider. And then also, the lever had to be offset from center, which changed up the design quite a bit. And then we also went through a few different iterations of our switch, and 3D printing was very helpful for that because we were able to get a lot of different designs printed quickly and make small changes.
As you can see, we were successful in achieving our problem. We were able to make a functioning tool that is able to chip ice in a timely fashion. Our client asked for a working tool, and we were able to deliver that to him, and we were able to make him very happy with our final product.
So we're excited for the custodial services to put this tool to use next year, and we hope to hear their feedback on it. But some things that we could think of if we could make improvements were to make a longer shaft or possibly have adjustability in the length for different users. Also weight reduction, maybe finding a tool that's a little bit less hefty. And then also making it so you can have interchangeable batteries so you can carry a spare and quickly switch them without having to stop and charge it.
So, yeah, my initial reactions are, like I think I said that already, it's really balanced. It looked in the picture like it was going to have, it's going to be hard to hold. And so the handle's really nice, really comfortable, not too heavy. A little bit loud, but, surprisingly effective. I think getting used to it, I put a lot of pressure on it at first and chipped some concrete. But if you just let it do the job itself, it's really effective. And I don't know, it's surprisingly a nice tool. I didn't think it would come out this nice. I was worried about the vibration would just kind of bounce, and this is the other thing, it doesn't vibrate in your hands, which is really nice. And surprisingly, this is actually fills your hand good here. A lot of handles are too narrow.
Yeah.
They wear down your muscles, but this is ugly. You get ugly. It's really, I wouldn't put that on a website, but it is effective. I think people are actually gonna like using it. I've got several areas where have like overhang and mounds of ice get built up, and so I can see something like that being really, really effective there. And asphalt, we didn't really try it on asphalt, depending on the softness, but I would imagine in the winter it wouldn't just scuff it up a little bit. So yeah, I think it's impressive overall.